Hello everyone, it's me, Professor Aaron Albert, here again with lesson 34. Let's learn some econ. So today we're just going to talk about Cournot equilibrium, which is different from what we did last time because they compete via outputs, not via price. So the reason this matters is if you've got a duopoly firm and they're sharing the market, right? They're not having a one person gets all of the market like we saw in Bertrand. You're facing sort of a residual demand, right? So you picture on the left, we have a monopolist. They set marginal revenue equal to marginal cost. Trace up to the blue demand line, get your price, and then they've maximized their profit. If you are a duopolist competing via quantities, it might be that you observe the full demand to be this light blue line. But if the other guy is selling, say, 64 units, you only actually can sell to what is called the residual demand. You can only sell to those people who are left. So that means your marginal revenue equals marginal cost is going to trace up to a different line. That's going to suggest a different price. And you'll note that this price in equilibrium will be lower because the demand you face is lower. The other guy sold a bunch of units, and that undermined your ability to make a ton of money. However, you can do that back to him. And so the question is, well, if you're competing via quantities, it does appear you can harm the other companies. When you sell, it lowers their residual demand. But how much do you want to do this? And how much do they want to do this? What is the equilibrium price? So what we're going to try to find is called the Nash-Cournot equilibrium. It is the Nash equilibrium in the Cournot game. In order to establish the Cournot game, we're going to resolve the game assuming four things. Only one of these is hard and fast. The other ones we will relax, and I'll show you that they don't change the way we think about it very much. The big thing that matters is the two firms are selling the same product, right? We have some demand for a product. Two firms both make that product. And each firm, therefore, faces whatever the residual demand is. The first thing you can relax is that there are two firms and that no one else can enter the market. We will assume that in order to solve what is called Cournot duopoly. If we instead assume that there are three firms, you have a Cournot triopoly. Four firms, it's a quadropoly. Right? You can assume any number of firms. But the classic and easiest way to do this is just assume you got two firms. So we're going to do that. Second, we usually will assume, for simplicity, that the firms have identical costs. You can relax this and solve exactly the same way, but again, for starters, we'll assume they have the same marginal costs. Lastly, firms set their quantities simultaneously. They go 1, 2, 3, go! And then they've released however many quantity that they've decided. We can relax this. If you relax this, it becomes the next game we'll talk about next lesson, namely the Steckelberg game. With this in mind, picture you get two firms simultaneously picking how much to make in quantity terms. That will influence the price that they can sell it for, and that they're both selling the same good. So their decisions influence each other. With this in mind, here, let me get out of the way. We want to find the Nash-Cournot equilibrium. That is the set of quantities such that, holding quantities of other firms constant, no firm can earn higher profits by choosing a different quantity of output. So let's see how we do that. So let's assume for first that our quantity is going to be given by 339 minus P. That is the demand of the entire market. And you have two firms. They each face marginal costs of 147. Cadet warm up. Solve for me what would happen if this is a perfectly competitive market. If this is a perfectly competitive market, we'd have infinite firms. They'd each serve as price takers. And people will enter the market until price equals marginal cost. If price equals marginal cost, that means price equals 147. Plug that into the demand function. Hopefully we get Q equals 192. Alternately, you could try to solve the same market in the case of monopolist. Again, let demand be given by 339 minus price and marginal cost set it to 147. See if you can figure out what the optimal price and quantity would be given a monopoly. Well, you'll note that the profit would just be price times quantity minus marginal cost times quantity. You could maximize that, or you could just note that marginal revenue found by multiplying the quantity equation, which you can get by inverting this, by quantity, set that equal to marginal cost, which is given at 147, you'll find that Q equals 96 and P equals 243. All right, now the new stuff. Let's suppose for a minute that we have two firms. Let one of them produce QA, let the other produce QU, and note that QU plus QA equals big Q, i.e. the total being consumed by the consumers. So your first question should be is, given this setup, what is the profit function for each firm? And then given that, what are the firm's optimization problems? Spend a minute, see if you can think it through. So the first thing you'll want to note is that profit for each firm is just going to be the price, which is given by our price equation, times their quantity minus their marginal cost times the quantity. Pretty simple object. If you take this, simplify like terms, namely this 339 is going to cancel out with this 147, you'll find that profit for firm 1 is 192 Q1 minus Q1 squared minus Q1 Q2. And firm 2's is the same. Just swap your Q1s and Q2s. All right, so if you're firm 1 and you're sitting there observing that your profit is 192 Q1 minus Q1 squared minus Q1 Q2, what are your choice variables and what are you trying to do? Hopefully you've noted that profit for firm 1 is decided by firm 1. All they can choose is Q1. Similarly, hopefully you notice that firm 1 probably wants to maximize their profit. So all you need to do is take the derivative of this with respect to Q1, take the derivative of this with respect to Q2. Try it out. Hopefully after you do that, you've noted that you have two similar looking equations. Namely, firm 1, after observing firm 2's quantity, namely QU, should output 96 minus Q2 over 2. We're going to call that the best response for firm A to whatever firm U is doing. Similarly, firm 2, firm U, should output 96 minus whatever firm 1 did, divided by 2. And again, this can be viewed as the best response for firm U to whatever firm A did. Our question now is, well, we have best response for firm A. It's some function of firm U. And we have best response for function for the firm U as in terms of firm A. What do we do? How do we solve this in order to get numeric values for QU and QA? What do you think? Well, there's two things you could note. First would be that this is completely symmetric. That is, firm 1's best response is the same as firm 2's, just they swap the letters. If you notice that, you could just also note that QA has to equal QU, has to equal QA. So just say 96 minus QU over 2 also has to equal QU. If you do that, you'll note that QA equals QU equals 64. This works as long as it is symmetric. Might not always be the case. There are things we could change to make it such that Q1 does not equal Q2. The thing you can always do, just plug the best response functions into each other. That is, we could look for QA of QU of QA. If you plug this equation into this equation, you'll find again that QA equals QU equals 64. Either way, QA equals QU equals 64. So, as I said at the beginning of this lecture, there's a bunch of things we could do to make this slightly less simple, but not that much more difficult. The first thing you could do is, well, imagine you don't have a Cournot duopoly. You got a Cournot triopoly. So in this case, we just assume that Q big equals Q1 plus Q2 plus Q3. But let's assume that the rest of the thing is the same. First question, what's the profit for each firm? Let's see if you can write them all down. Hopefully you noticed that this is identical to what we had before, just rather than Q1 and Q2 being subtracted from the 339, we have Q1, Q2, and Q3. Easy enough. Now what? What are the firm's objectives and how do they do it? Well, all you gotta do is take FOCs. Firm 1 can choose quantity 1 and wants to maximize profit 1. Therefore, you could take the first derivative of this with respect to Q1 and get best response 1, i.e. firm 1's best Q1, which will be a function of Q2 and Q3. Similarly, for firm 2, you could take derivatives and solve out for the best response for firm 2 to the quantities output by Q1 and Q3. And then you do the same thing for firm 3. Then you'd have 3 equations you could plug all into each other, and you'd resolve some Q1, Q2, and Q3. In fact, you can do this for any number of firms, any n firms. And you should note that the more firms you have, the closer this gets to perfectly competitive markets. And in fact, if you have infinite firms, this math will actually turn into perfectly competitive markets, i.e. price equals marginal. Okay, and one more thing you could try is you could try solving a situation where the two firms don't have identical marginal cost. That is, they don't have completely symmetric profit functions. Suppose, again, that we have two firms engaging in Cournot duopoly. This time let your demand be given by 25 minus 3p. And this is the demand for the market. Let the marginal cost for firm 1 be 2, which is not equal to the marginal cost for firm 2, which is equal to $3. Using marginal cost 1 equals 2, marginal cost 2 equals 3. In this case, what's the profit for each firm, and what's the optimal Qs and P? Let me know how you do. Thanks so much. See you next time. Bye.